Ask My Instructor 11.3.18. Find the points at which the polar curve has a horizontal or a vertical tangent line. Notice that theta runs between 0 and 2 pi. What do we mean when we talk about the slope of a graph that is given in polar coordinates? The slope of a tangent line is its rise over run ratio, but rise over run refers to x and y. In effect, we are asking what is dy dx at r theta. To find dy dx at r theta, we use the fact that x equals r cosine theta, y equals r sine theta, and replace r with its equivalent form f of theta. Using the parameterization, we get dy dx. I often like to write dy dx either this way or using this form, this last form here. Now if you use the last form, you have to keep in mind that r is a function of theta. To find where our graph has horizontal and vertical tangent lines, we're going to use the following strategy. We're going to find dy dx. We're going to find where the numerator is 0. We're going to find where the denominator is 0. Now, excluding duplications, where the numerator is 0, you have a horizontal tangent. Where denominator is 0, you have a vertical tangent. For places where both the numerator and the denominator are 0, we have to use another method, such as L'Hopital's rule. Find dy dx. Alright, so set up dy dx. After we do the setup, go ahead and take the derivative. Now we have to clean, wait. Don't clean it up. Do not simplify. Now why is that? Remember I said we have to worry about duplications, and we don't want to do any kind of canceling. So instead, we're just going to find where the numerator is 0. So simplify just the numerator and set it equal to 0. Alright, so where does the numerator equal to 0? I factor out 2 cosine theta, and I get two solutions. Cosine theta is 0, or sine theta equals -1/8. Finding where cosine theta is equal to 0 is a pretty straightforward process. Finding where sine theta is equal to -1/8 is not a straightforward process. This takes a lot of work, and you have to remember inverse sine and how it works. So inverse sine or arc sine is an angle, and that's what we're going to have to use. Sine is negative in quadrant 3 and 4, and the angle inverse sine by definition will be in quadrant 4, located about where the arrow is pointing. Why am I saying that inverse sine will be in the 4th quadrant? Well, -1/8 will give me a negative angle for sine, so I have to be in the 4th quadrant. Keep in mind that the inverse sine function gives an answer of an angle between -pi/2 and pi/2. That's why I keep insisting that a negative angle would have to be in the 4th quadrant. Alright, in fact, it's equal to about -pi/25. Alright, now this is just by definition. When you say inverse sine, your answer has to be between -pi/2 and pi/2. And our angle has a sign that's negative, so it has to be in the 4th quadrant, given as a negative angle. So if we take our angle and add 2 pi, we will get one solution that is positive, and we need our solution to be positive because theta is between 0 and 2 pi. The second solution will be opposite the first solution, and it will be sitting in the 3rd quadrant. And how you find that is you take that angle inverse sine and you add pi to it. You take the angle inverse sine, you make it you make it negative, which is finding its absolute value. So you make it negative, finding its absolute value, and you add pi. And so our second solution is going to be pi minus the inverse sine, which is about 26 pi over 25. And so these are our 4 solutions. Find where the denominator is 0. Now, finding where the denominator is 0 takes even more work. Okay, why is that? Well, simplify the denominator and set it equal to 0. What you end up with when the dust settles is a quadratic formula. So now, not only do we have to work with inverse sine, we also have to work with a quadratic formula. All right, so set up your quadratic formula. Once you set up your quadratic formula, you want to simplify. And so these are the two places sine theta equals this algebraic expression or the other algebraic expression. All right, how about the first one? Well, let's see. -1 plus radical 129 over 16, that's a positive number. So inverse sine of that algebraic expression is going to be a positive angle. So inverse sine of a positive number will be a positive angle. All right, so it doesn't need any adjustments. It will be a number between 0 and 2 pi, and in fact it's going to be in the first quadrant, and it's about 22 pi over 100. It's right about there. Okay, now the other guy is going to be opposite, so just go straight across to the other side. Now how do you go straight across to the other side? Well, basically you're going pi, and then you back up the amount of angle that you just found. So you go pi minus that inverse sine. Okay, so the opposite, that angle, would be the other solution, pi minus that inverse sine. So the other guy is right there. Okay, now where is sine theta equal to? -1 minus radical 129 over 16. Now notice this time I'm dealing with a negative number. The angle who has a sine, the sine of the angle is a negative number. That means my angle is going to be negative, which means, remember, I'm going to have to, I'll end up with a negative angle, but I can't have a negative angle, so I have to add 2 pi. So take that value, take my inverse sine and add 2 pi, and that'll give me something that's positive, and it will be in the fourth quadrant. And then opposite that, same as before, you have to go pi minus that, and so those are my other two solutions. Okay, now step 4, excluding duplications. Let's just stop right there. We have no duplications. Now that's really good because it means we can skip step 5. Excluding duplications, where the numerator is 0, you have horizontal tangent lines. Okay, so this is where my numerator was 0, and so I just set up a table. Now recall that these two angles here are where my sine theta is equal to -1/8, and so nothing special is required for evaluating r. And then the other two angles, they're pretty straightforward as well. So you just simplify, and if you want to, you can plot the points, and they're located there. Okay, how about your verticals? The verticals are found where the denominator is 0. And this is the locations where the denominator is equal to 0. For the first two angles, those are solutions to my -1 plus radical 129 over 16. And so r should be pretty straightforward there. And then for the other two guys, those are also solutions, and so use that to your advantage. You don't want to have to like go through all the thinking process again. And then after the dust settles, you get these values. Not very pretty, but that's where they're located. Now, just a reminder, we did not have duplications. Therefore, we do not have to do step 5. There was no place where the denominator and the numerator are both 0. And that's excellent. It makes our life much easier, which is good because the problem was hard enough as it was. Take care. Have a great day.